Welcome to Ask and Learn.
Okay, so first things first, we want to write out our equation. So I have it written here. We have I2 plus H2 going to HI. And anytime we have an equation, we want to make sure it's balanced. So you see on this side, we have two I's and two H's, which mean on this side, we need to put a 2 here in order to balance the equation. Perfect. So we're first asked if the Kc is greater than 1, equal to 1, or less than 1. So the best way to do that is to find the Kc. So to write our Kc expression, we're going to do products over reactants. So we're going to put our Hi here, and then I2 and H2 here. And remember, you always raise the concentration to the power of the coefficient. So Hi is going to be raised to 2. I2 and H2 would technically be raised to 1, but we can just leave those out. So we'll just leave it out. Perfect. So now we have to find the concentration of I2 and H2 and Hi from the picture we are given. So if you count, we have 10 HIs in the picture, 2 I2s, and 1 H2. So we're told that each molecule is 0.01 mole, and it's in a container that is 1 liter. So in order to find the concentration, we can say 10 molecules of HI times each molecule being 0.010 moles divided by 1 liter. So this is our formula for concentration. So moles over liter gives us molarity. So this will give us 0.1 molar. So HI is 0.1 molar. And then we're going to do the exact same thing for 2. So again, we're multiplying, or for I2, we have 2 molecules, so times 0.01 mole, again, divided by 1 liter. And that is going to give us 0.02 molar. Now try and pause the video and do H by yourself. So again, you're going to do the exact same thing. And you should come out with 0.01 molar. Okay, so next we just have to plug these into our Kc expression. I've written another one right here. So we're going to put our Hi. We have a concentration of 1. Again, always remember to square it. And then we'll have 0.02 down here and 0.01. Now you just have to solve, and then you can find the Kc. So the Kc should come out to 50. So it is greater than 1. All right, let's move on to the second part of the question. So we're asked how Kp is related to Kc. So we can use this equation. So Kp equals Kc times RT raised to delta N. So delta N represents the number of moles of product minus the number of moles of reactant in the chemical equation. So we don't need to count. Again, we don't need to use these numbers that were given in the picture. We just need to look at these moles. So we know that there are 2 moles as product, and then 1 mole of I2 as a reactant and 1 mole of H2. So we know there are 2 moles of reactants. So this would be 2 minus 2, which gives us 0. And if we put this as 0, RT to the 0, raised to the 0, is just going to be 1. So that leaves us with Kp equaling Kc. There we go. And the last part of the question is asking us to find the delta G of reaction. So again, we're going to use this equation like we always do. Oh, that was not what I wanted to do. our delta G of reaction equals delta G of the products minus delta G of the reactants. So you can go ahead and plug in. I like to make a little skeleton here so we know exactly what we're plugging in. Delta G of HI minus the delta G of I2 plus the delta G of H2. And remember, we want to include the coefficients, but since we want the delta G of the reaction specifically for the picture that we're given, we want to use these concentrations. So we're going to put this 0.1 times the delta H, or the delta G of HI, and then we're going to do 0.02 times the delta G of I2, and 0.01 times the delta G of H2. And so, again, we're doing this because usually we would use this, our chemical equation. So we do we'd use the coefficient. So we do 2, 2, and then, or 2 for our HI, and then 1 for our H2, and 1 for our I2. But since we're asked about the specific mixture that we're given in the picture, we want to use those concentrations that we've calculated up here. So you should be able to find these values in your appendix, but I'll put them here. So this is 1.3 kilojoules, and then times 0 kilojoules times 0 kilojoules. So the answer should come out to be 0.13 kilojoules for the delta G of reaction. So the last part of the question asks you if the delta G of reaction would change if you changed, if you pretty much swapped these two. So the I2s all became H2s and the H2s all became I2s. And the answer is no, because both of these have delta G standards of 0. So it doesn't matter what you change this coefficient to, it's always going to be 0. So it will not affect the delta G of reaction.